Welcome back. Let's talk about Friedel-Crafts alkylation and Friedel-Crafts acylation. And I did fix the handout, so let's see if this one is correct. All right, so we already did this page. Let's see. Friedel-Crafts alkylation. Oh, yep, there's the problems. All right. So Friedel-Crafts alkylation and Friedel-Crafts acylation is just another reaction of electrophilic aromatic substitution, only we're going to add carbons on. So alkylation means put in an alkyl group or an R group. Okay, so put a carbon on, where acylation means put a carbonyl onto the benzene. All right. Well, that begs the question, how are we going to get a carbon on there? And the answer is it has to be some form of a carbocation. All right, so carbocations. And so I'm going to go over to the whiteboard for this one, but just as a nice review, the first step, of course, is the formation of that really super electrophile, and in this case, it's a carbocation. And we're going to look at alkyl halides, we're going to look at alkenes, and we're going to look at alcohols, but don't forget, any carbocation-like species is going to fall under this rubric. All right, whiteboard. All right, so Friedel crafts alkylation. I am just looking for a carbocation. All right, so let's look at alkyl halides first. For the alkyl halides, we are going to have to consider primaries, secondaries, tertiaries. Yes, but don't forget, carbocations, look out for rearrangement. Okay, so never forget that. Okay, so for the alkyl halides, let's look at a primary. We would again react this with a Lewis acid. I was going to put aluminum and then iron. Let's put aluminum bromide or aluminum chloride. Okay, so the same thing is going to happen. We're going to make that complex. And so this is going to be negative. This is going to be positive. Now, right here, after I make that, if the carbocation is stable, it will actually pop off. But if it's not, like for instance, this one would be a primary carbocation, so this one would stay attached to the rest of the group, but it could literally detach if it's a stable one. All right, and then the same thing is going to happen. Then my benzene is going to come along and, oops, there's supposed to be a 3 there. Whoa. Okay, then it will kick out that. Oh, this looks so familiar. And it will create a benzene now with an alkyl group on it. Okay, well, that doesn't seem too crazy. Let's just look at our variations here. That was a primary. Let's just take a look at a secondary. So that one would create let me see, I missed, oh, that's supposed to be a chlorine. This one might spontaneously pop off. And so instead of the complex, it could be a carbocation just on its own. Well, and a tertiary would be the same. Beware, tertiaries are getting pretty sterically hindered. And again, this one probably will pop off because it's a stable carbocation. And then don't forget, there's always the chance of rearrangement. So for instance, this one would originally form and it would pop off as, but it would rearrange to the more stable tertiary one. So if you want that to happen, absolutely, it's no big deal. But if that's not the molecule that you actually wanted to put onto your benzene, just choose one that can't rearrange. So those rules are still in effect. Look out for rearrangements every time you have a carbocation. All right, so that's your alkyl halides. Let's look at your alkenes. The alkenes, you just have to get into a carbocation form, so some kind of an acid. Usually it's not the binaries because you don't want chlorine to be a competitor. All right, and there you go. Watch out for rearrangements as well. Let's see, so let's put that there. And if we did there, the first one would be this one, but it would rearrange to the more stable one. And so under those conditions, you could put an isopropyl group on. Okay, so there's alkenes. So alkenes have to have your acid. Well, guess what? So do your alcohols. Again, with an acid, you've converted it into a good leaving group. And again, secondaries and tertiaries will actually pop off, but the primaries will probably stay like this, and the benzene will actually kick the water off. All right, so we've seen alkyl halides, we saw alkenes, we saw alcohols. That's how we can get just a carbon group onto a benzene. Well, what about carbonyls? That would be called Friedel Crafts acylation. And you would use either an acid halide. Oh, that's supposed to be an E. An acid halide or an anhydride. All right, so an acid halide, we haven't really used this functional group other than memorizing it a long time ago, but that's an acid halide. And this one, an anhydride, has an oxygen in between two carbonyls. They both have great leaving groups. That's the power behind acid halides and anhydrides. So if I put that in the presence of my Lewis acid, guess what? And the lone pair on the oxygen would automatically come and kick that out into, and I'm just going to put that as an R. And there's the key to the Friedel-Crafts acylation. It's the formation of this anion. Okay, technically it's a carbocation, but it has its own name. So gonna go over to the notes. All right, so for Friedel-Crafts acylation, okay, where are we at? Where the uranium ion? I know I have it written somewhere. Da, 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 da. Oh, right there. It's not uranium, it's Acylation. Don't ask me what I was thinking there. Obviously, I'm not. That is the key for all of the variations, all the variations. All right, so acetyl means when you attach this, there's two carbons. So ACETYL means there's two carbons. Okay, so that's a very common one to put on. You can also put larger groups on, but just so you understand what acetyl mean. Okay, how are we going to make the acid halides? Because that's not something you usually just go grab off the shelf. They're so reactive. So you can take a carboxylic acid with either thionyl chloride or phosphorus pentachloride, and you can create your acid halide first, or you could use an anhydride. So I am going to go back to the whiteboard. All right, so this one right here, if I wanted to create it, I would have taken a carboxylic acid and I would have used SOCl2 or PCl5, and I would have created my acid halide. So technically that's a carboxylic acid reaction, but you usually have to make those in situ because they're so reactive. You don't usually just buy it and then pour it in. All right, so that's how you would make an acid halide. You'd start with the carboxylic acid, and then the anhydride, you actually can't start with those. And this one happens to be called acetic anhydride. It's the same one that you've been using to make your aspirin and your acetaminophen. And it has that really, really pungent, like vinegary smell. All right, clear this off. All right, so benzene. So this is very common. We're going to start stacking reactions on top. So once we have created that, then we're going to put in our Lewis acid catalyst. All right, so this step right here is the formation of my acid halide. So step one is this plus that, which really makes that. Okay, so that's what you're supposed to see from that top line. And then we're going to add what in with it? We're going to add in the aluminum chloride. And so for step two, this is what you're supposed to be seeing. And that is Friedel-Crafts acylation. And so this together is supposed to look the Acylation ion. That's what you're supposed to be seeing. Kicks out that lone pair. And it's just the same as all the others for electrophilic aromatic. And then we have to come and rip off. Okay. Now, who am I going to use to rip off? In this case, I'm just going to put the Cl minus. Wait a second, you can't reform a strong acid. Okay, somebody will come along and kick that off. And I have introduced a carbonyl group onto my benzene. An acid halide is very similar. It's very similar. Not an acid halide, an anhydride. Although I don't have to make the anhydride in the first step. So it would just look like that. And I would still end up with that ion. All right, so that's Friedel-Crafts acylation. Okay, now some interesting things about Friedel-Crafts alkylation and Friedel-Crafts acylation, and technically the other ones above it, is once you put one thing on benzene, you're either going to activate benzene and make it more reactive, or you're going to deactivate that benzene and make it less reactive. And so here's just a little summary. When you're doing alkylation or acylation, beware. When carbocations are formed from either the alkyl halide, the alkene, the alcohol, just beware. Do not forget that if you ever go through a carbocation, it can rearrange. All right, very poor yields are obtained when there's a very powerful electron withdrawing group on the ring. And that probably sounds familiar because when we were doing the resonance and aromatic handout, I had you look at what are electron donating and electron withdrawing groups. So I am going to go into that in more depth, but just know that if you have really powerful electron withdrawing groups, that's a bad thing. Or when you have really good electron donating groups. Now, I didn't put right here oxygen, but don't forget oxygen. So the OH, OR would also work in that case. All right, polyalkylations, it'll happen more than once, will occur if you have donating groups on it. And polyacylations do not occur because you have an electron withdrawing. Now, I know that seems like, well, that doesn't make any sense to what we just did. It leads into the next section. So I'm going to go talk about those activating groups and deactivating groups, and then I will come back and then say, oh, here's how this applies to Friedel-Crafts alkylation and acylation. But know this, alkylation, okay, alkylation puts an electron donating group on your benzene, and acylation puts an electron withdrawing group on your benzene. And so we have to take into account what that is going to do for future reactions. Okay, Friedel-Crafts alkylations versus Friedel-Crafts acylations. And then here's the problems that I told you were missing from the last one. So if you never saw that old handout, this is the one that should be on Canvas now. So that first question is just go through and do the generic electrophilic aromatic substitutions. And then can you come up with the reagents to create each one of those? And that's just a few problems for electrophilic aromatic substitution. The next video, we'll talk about, hey, what if there's already something on the benzene? What is that going to do to the benzene? Is it going to make it more reactive? Is it going to make it less reactive? And then if it does react, where would it put it? Okay, what location? And that's called a director. All right, but that sums up Friedel-Crafts alkylations and acylations. So until next time, jolly out.